Good morning, boys and girls, and welcome back. Today we're going to talk about constructing a power series off of some of the Maclaurin series and Taylor polynomials that we already know. We're going to find the first four terms of a power series for the functions that I'm going to give you, and hint, you might want to use like substitution, maybe some integration, some multiplication. I've kind of alluded to a lot of these tricks before in previous videos, but now we're going to put them to use. Alright, so here we go. Here is our first one. And before we get started, if you have your homework sheet out, I'm just doing basically some random ones off your homework sheet. You can complete them so that I'm doing half your homework for you. Bonus part of notes today, right? I get to do half your homework for you. Alright, here we go. Here is the first one we're going to do 1 over 1 plus x about c equals 0. So again, I think the first thing you're going to want to do is try to find something to compare it to, something that we know. So in this case, I think we should use 1 over 1 minus x, since we know that one and we have that Maclaurin series memorized, right? And so what I'm going to try to do is I'm going to try to, again, make the one we're given look like the one that we know, all right? So instead of that plus, I'm going to have a minus sign. So the way that I could rewrite this is 1 over 1 minus a negative x. That's still 1 plus x, again, just written in a different form, but now it's in the same form as the one that I know. Right? And so I can use substitution in this case, and in our series that we know, instead of having an x, I'm just going to plug in an x every time. So we know that 1 over 1 minus x equals 1 plus x squared plus x cubed. Those are the first four terms. So now I'm just going to plug in a negative x, substitute a negative x for all those x's. And we get something that looks like that. And now I can just go ahead and simplify that. And here is our power series for 1 over 1 plus x. And we get 1 minus x plus x squared minus x cubed plus ... going on forever. But we just need the first four terms. All right, so we create our first power series. See, a little bit. I think this day is a little bit nicer than where we've been in the past. We tend to, enjoy this day a little bit more. All right, so same thing here, but let's get a little spicier. We want to write the power series for 4 over 5 minus x about c equals negative 2. In this case, again, I think this looks a lot like our 1 over 1 minus x. So let's use that same power series to write our new power series. And the first thing we're going to have to deal with also, if you notice on this one, is that we have shifted our center. Our center's gone from 0 to negative 2. So the first thing you're going to want to do is you're going to want to shift the center in your new function so that it's at the right spot. So we are going to use x plus 2 to shift that center left 2. All right, so instead of an x, I'm going to put an x plus 2 in my original equation. But again, I want to change the way things look, but I don't want to actually change the equation. If I just leave it like that, if I simplify that, that's not going to be exactly what we started with. So I need to fix as I move along. So if I put an x plus 2 in there, this would really give me, negative x minus 2 if I distribute my negative. So I don't want to change anything. So if I, my minus 2, if I add 2 at the same time, when I simplify this would still give me my original problem. All right? And if I go and combine the 2 and the 5, now I get 4 over 7 minus x plus 2. And again, if you went and simplified this, we'd still end up with our original problem. I'm trying not to, again, change what it is. I'm just trying to change the way things look, while at the same time making it look like the function that we know. I'm trying to make it look like that, but keep the numbers the same, the values the same. All right, I guess the next step to make it look like this, again, I want 1 minus something, right? Like last time we had 1 minus negative x, but I need 1 minus some value. So I need to get rid of this 7 in the 4 over 7 minus x plus 2. And so what I'm going to do is I'm going to come along and I'm going to divide that by 7 to make it a 1. All right, so if I want to divide that by 7 to make it a 1, what I really have to do is I'm going to have to divide everything on the bottom by 7. Right? Divide the bottom of the fraction by 7. And then I'm also going to have to divide the top of the fraction by 7. I'm technically like reducing this fraction, divide by 7 on top, divide by everything on the bottom by 7. But now again, what that allows me to do is make this look like our 4 over 7 over 1 minus x plus 2 over 7. So we're getting it to look, again, more working towards that form that we know. Now the last step is I need a 1 on top of this thing up here. So I'm going to factor out that 4 over 7 and rewrite this as 4 over 7 times 1 over 1 minus x plus 2 over 7, right? 1 over 1 minus u. Now I'm in that form, and so now I can use substitution. So our 4 over 5 minus x would be equal to 4 over 7 times that Maclaurin series 1 plus x squared plus x cubed. But instead of plugging in x, I'm going to plug in my x plus 2 over 7 instead. And so I'd get something that looks like this. This would be a great FRQ answer. I would not touch that from here if this were an FRQ. However, again, I might need to do some simplifying to make it match a multiple choice. I might have to do this and simplify my exponents. Again, at least on the bottom parts, the top parts, we leave it in that x plus 2 form. And then now I distribute the 4 over 7. And you get 4 over 7 plus 4 times x plus 2 over 49, plus 4 over x plus 2 squared over 343, plus 4 over x plus 2 cubed over 2,401. But that might be my multiple choice answer. But this is how, again, we can, take a Maclaurin polynomial that I know and use substitution to help me get to a new one. So again, just quick little review. This one things did is we first worried about our center, and then we started to try to make it match the Maclaurin polynomial we know by tweaking little things. Again, always adjusting when we tweak, and then we had our multiple choice and our FRQ answer. All right, moving on. Number 3. All right, this is kind of similar to the last one, just some different tweaks to it. But now I want to do one for 3 over 2x minus 1, and again, about c equals 2. So we're still, again, going to use the 1 over 1 minus x. I want to try to make it look like that. In this case, I think the last time I said the first thing I'm going to do is use my c and get the right center. But in this case, because we have a number in front of my x, I think I'm going to try to get rid of that first so that when I plug in that x plus 2, I'm going to have minimal work to do around it. So I think the first thing I would do in this case is I would divide both of the top and the bottom by 2. If I divide both the top and the bottom by 2, I get 3 halves over x minus 1 half. And now that x is by itself, now I can worry about my center. So now I'm going to make my center at x minus 2, right, to center it at 2. And again, so when I plug in that x minus 2, if I'm going to minus 2 from the bottom, then I also need to add 2 to the bottom so that they kill each other off. And then again, it's remaining the same thing. So now if I simplify, I end up with 3 halves over x minus 2 plus 3 halves. You might be seeing our form starting to take shape here a little bit. This is getting close, although again, I want it 1 minus u or 1 minus x, not x plus, the 1. So I'm going to flip this around. And now my only issue is I've got 3 halves on the top and I want a 1, and I got 3 halves in front and I want a 1. So a quick, easy fix for this would be to multiply everything by 2/3, both the top and the bottom. And so if we distribute 2/3 on the top and the bottom, we end up with 1 plus 2 times x minus 2 over 3. And now again, we're really close. I got 1 over 1 plus, but I want 1 over 1 minus. So I need to do that little sign trick and, minus and negative. So this is that same function we started with, again, just written in a slightly different form, so that I can now use my rule for 1 over 1 minus x. And I'm going to plug in negative 2/3 x minus 2 in for all my x's. And so when I substitute in, I get something that looks kind of like that. And then again, like FRQ answer, this is great. I could stop right here. And if not, I could keep going, and simplify some more if I had to. For this problem here, we're going to stop right here and just leave it like that and enjoy our FRQ answer. All right, now if you're following along with me on that packet that I gave you, you're now going to want to switch and turn to problem 7. The ones in between here, 4, 5, 6, you will do those on your own for homework tonight. Normally in class, this is very similar to one we've done already. I kind of let you guys walk me through this one. But again, if I'm going to use 1 over 1 plus x squared, that looks like 1 over 1 minus x. So maybe I'd rewrite this as that right there. And so now I just need to plug in negative x squared, and we would end up with this power function right there. Or again, this one's not too hard. We can maybe go and simplify it and get 1 minus x squared plus x to the 4th minus x to the 6th. The reason, again, this one's kind of easy, and we've done something like this already, but the reason I do this one is more for number 8. So you have it for number 8. So hint. And there's a slight hint on number 8 when you look at it, but there's a connection between 7 and 8 as you're playing with these tonight. All right, we're going to move along to number 10 now. And 10, again, just going to move to a new function, but kind of the same idea. We want the function, the power series for sine of 2x. So in this case, I think we'd use sine of x. So if you remember, the Maclaurin series for sine of x is x minus x cubed over 3 factorial, plus x to the 5th over 5 factorial, minus x to the 7th over 7 factorial. But now, again, we're just going to use substitution, and we're going to plug in 2x for all those x's. So you can see, once you get the hang of this, it's really not that bad. And again, we could do some simplifying here, but we're going to leave this one just like that. And we're going to move to number 12. All right, we want to write the power series for x squared e to the x, centered at c equals 0. All right, and I think we did one like this earlier on in one of our earlier videos and earlier set the notes, similar to it, not the same, but similar. But again, we don't just have to use substitution. We can also use like multiplication sometimes. In this case, we know e to the x. E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot. But I know that one, so if I want the one for x squared e to the x, I can just take this Maclaurin series and multiply everything by x squared. So we're going to do something that looks like this, and our answer would look like x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial, and so on. All right, one more. We're going to look at number 15. Okay, so for 15, we want to write the power series for e to the x over 1 minus x, and about c equals 0. So for 15 here, I guess maybe the first thing I do is rewrite this as, this is really equivalent to e to the x times 1 over 1 minus x. And so I guess we know both of those series. This would be something like 1 plus x squared over 2 factorial plus x cubed over 3 factorial. That's e to the x times 1 plus x squared plus x cubed. And that's our 1 over 1 minus x. And now I just got to multiply those together. Now, that might seem kind of bad, but I don't actually have to multiply everything together. And we can kind of maybe shortcut trick this a little bit. If we're looking for just the first 4 terms, I don't have to multiply everything, especially because technically these things go on and on forever, right? Plus dot, 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 dot. But I just need those first 4 terms. The constant term, the x term, the x squared term, and the x cubed term. All right? So let's try to condense and just find those terms. Well, I guess the only way to get a constant term would be to multiply the 1 times 1. So the constant term would have to be 1. Now I want to find all my x terms. And the only way we would get an x term when we distribute is by doing the 1 times x, or the x times 1. Okay? So this would be plus, and I'm going to say I'd get 1x, and then I'd have plus another 1x. So I could simplify it, like that, so I'm not actually multiplying out and, combine them like terms. I can just kind of think about what's going to happen. And I can do the same thing for the x squared and the x cubed terms. To get an x squared term, that's going to be my next term here, right, as an x squared term. To get an x squared term, I'd have to multiply, let's see here, we'll start in the front. 1 times x squared would give me x squared. And then x times x would give me 1x squared. And then x squared times 1 would give me an x squared. So that'd be a 1 over 2 factorial. You try to squeeze all that in there. So 1 plus 1 plus 1 over 2 factorial would be all of my x squared terms. And so that'd be, those 3 I'm going to add together to give me that 1 term. And now, last but not least, I'm going to do the same thing for the x cubed terms. Okay, so to get my x cubed terms, 1 times x cubed is 1x cubed. I'd have x times x, I didn't have a squared here. 1 times x squared, I think I erased it when I erased my marks. 1 times x squared is x squared, or is x cubed, so that's again another 1x cubed. Then I'd have x squared times x, so this would give me plus my 1 over 2 factorial x cubed. Or then I could do x cubed times 1, and this would give me plus 1 over 3 factorial. And that would be all my x cubed, all the ways I could get x cubed terms. So now I just got to simplify this. And we've got our polynomial approximation for e to the x over 1 minus x. All right, that's it for today, boys and girls. Finish this worksheet and have a good day.